Hey there, Nick is here. In this video, we're going to go over how to bind to a load port as a non-root user when you run a process in a container with Docker and Kubernetes. This video is going to be some type of hybrid video where we're going to go over this blog post that I wrote out just before here. Of course, not word for word. And we're going to be running some commands, looking at some Kubernetes configs and applying things and looking at the outputs. But I feel like it is pretty important to kind of set the stage for this one because there's a little bit of knowledge, I guess, beforehand that will make sense before we start looking at solutions. And of course, if you want to jump around, feel free to look at the timestamps there and find the answer in about 5 seconds if you'd like. So yeah, let's start cracking here and just, identify what is even a load port. So a load port is anything under 1024 on a Linux system by default. And there's a couple of ways you can modify that one. One is using sysctl, which is basically a way to modify Linux kernel parameters to run something like, a web process as a non-root user on port 80 and not get some issues. Spoiler alert, that is one solution that we're going to go over here, and my suggested one if you can't change to a high port. But yeah, let's go over things in order here. So yeah, depending on what process you're running, maybe Nginx, Apache, or some other reverse proxy or web server, you may have seen an error similar to this one, where it's basically saying permission denied when trying to bind in port 80. Of course, the exact wording of this is going to be different depending on what tool that you use, and it's not really specific to Docker. Technically you can get these types of errors without Docker as well. But yeah, this indicates that you're trying to run a process on a port that usually requires root privileges or some type of escalated privileges here. And it's not limited to port 80 either, right? It could be 443 or anything under 1024 by default. And normally, yeah, at least in a Docker context here, you would only encounter this type of thing if you're running your process as a non-root user. And for security purposes, I actually think that's a great idea. And I've written about this topic in the past and also made some YouTube videos. I'll link to cards, descriptions, etc., etc. And by the way, this is linked we're looking at this here on localhost. It will be on my main website by the time this video goes up. I'm going to link everything in the description there if you want to check it out here. So yeah, there's a couple of different ways that we can solve this, right? And all of them do not require modifying any system settings on your Docker host, if you happen to be running something like Docker Compose on one server or your Kubernetes nodes. Instead, we can make changes to either our app's config, or we can set a Docker or Kubernetes config option that's isolated to a specific project, right? Some, Docker Compose YAML file or whatever Kubernetes config that you have here. So here's 3 different ways you can fix that type of error. And I'm sure there's more, as I mentioned here, but in this video and post, we're only going to be focusing on these 3, more specifically the top 2, but we are going to completely go over the 3rd version as well, and why I would suggest using version 1 here or version 2, depending on your use case. But before we get into, going over each solution here, I think one really important question to ask and answer is, is it less secure to use a lower port, or is it more secure, or, basically things like that? And the answer is not really. They're all the same. So at a fundamental level, listening on port 8080 and 80 do the same thing. One isn't more secure than the other. If you're talking about raw functionality of what happens when you bind to that port, you could make a case here, right, that instead of listening on something like port 22 for SSH, you may want to listen on, 23617, right, or some other random high port to allow or to avoid low-hanging fruit there, where someone may want to try to connect to your default SSH port, right? If they know that it's on 22, then they can immediately access it. If it's on a higher port that's random, then, well, it's going to take quite a few attempts there to maybe find that one because there's a lot of different ports, right? 65,000 of them. I guess a little bit less here if you ignore the lower ports, but yeah, whatever. So sure, I'll generally agree there that using a higher port is a good idea, maybe, but it's actually not more secure in the end, right? Because anyone can just port scan you in a couple of minutes or whatever and find that custom port in the end. Or you're really saving a little bit of time. But yeah, if somebody really wants to connect to your port, they will find it and they will connect. So please don't just solely depend on security through obscurity. That's a whole other topic in itself, right? Security in general, treat it like an onion, right? It's really good when in layers. So if that's not the case, then if security really isn't the focus of that, why do we actually even have low and high ports? And low ports are technically registered ports. They're well-known ports for very common services like SSH, DNS, web stuff, and email, and so on. And in my opinion, right, you should not use these lower ports for anything but their intended use here. But technically, if you wanted to be a maniac, you could bind SSH on port 80 if you wanted to. Nobody's stopping you there. But yeah, again, really wouldn't mess with these well-defined registered ports here for common services. It's going to confuse a lot of people, probably your future self as well. But, having these low ports require root access is completely reasonable. If you rewind time back to a couple decades ago, right, where you might have one server with many, many different user accounts on them, folks other than yourself. You surely wouldn't want average Joe or plain Jane to bind to port 80 on your server as a regular user to run something custom. That would be kind of a mess, right? So Yeah, even today though, in a single user, single environment, if it's just yourself there, I also think it's pretty reasonable to have this requirement here because it's a really good reminder that you're interacting with something at a system level, or more generally, a semi-formally reserved port. Right? It's a nice little hint or a reminder that, hey, I'm kind of doing something special here. Like, I hope I know what I'm doing here. But what about containers? And I think this is actually where things get a little bit more interesting, right? If everyone has their own isolated network, should you really need root access to be able to bind to port 80? But more importantly here, like what if you factor in wanting to do the right thing here and make your application more secure by running it as a non-root user and also completely disabling privilege escalation altogether, right? You can't even run any sudo commands or just like, sudo as root and check things out there. For example, you may choose to listen on ports 80 and 443. This is for HTTPS with Nginx or Apache, but have them fully configured to run as a non-root user. And if they're running as a non-root user, then how are they going to bind to those ports, right? So, these are also web servers, reverse proxies, blah, blah, blah. It's totally normal to want to bind to these ports, right? You would want that to be HTTP and HTTPS there because that's what these processes do. So you could say, well, that's pretty easy, right? I'll just bind it to 8080 and 4430 instead, and then put something like a load balancer in front of them. And you could totally do that, but like, what if you don't have a load balancer? And we'll get into like how that works if you wanted to do it this way once we start looking at solutions. But yeah, literal segue into that. Now let's look at a few different ways to solve this issue. So you can easily do it, right? If you want to go to a high port, and it's actually not a bad idea if you can do it easily. I would suggest doing that one. For example, like if you have something like a dedicated load balancer in front of your reverse proxy like Nginx, then yeah, there's no harm at all in configuring Nginx to use a higher port. Since the internet, example.com is going to be hitting your load balancer that's listening on port 80, maybe redirecting to 443 there. So nobody's going to have to type in like a port when they want to access your site. Like in this case, localhost :4000 here, 4000 is the port, but it's just running on my dev box. Like when you go to nickjonatakis.com, you're accessing just nickjonatakis.com. The browser is putting in the default port for you because I don't have any custom high port there. So that's one option there if you want to do that. But personally, I happen to run Nginx outside of Docker for single server deploys. And I have a blog post about this one. I'll link to that. So, I really don't run into this high port issue with Nginx because Nginx is running outside of Docker. It's running at whatever the default user is on the actual system level, which does have permissions to bind to port 80 and 443, and everything just works here. But I have worked for quite a few different projects, contract work there with Kubernetes where maybe you have something like a web application running in a container with Apache as well. So you have two different containers running in a single pod. So now both the reverse proxy and the web app are both running in a containerized workload. And I understand that the real world happens for other reasons too, right? Totally, completely fine to run a whole classification of apps on one server without a load balancer. So maybe you can't really use a high port because Nginx or Apache or whatever you're using is being directly accessed from the internet. You wouldn't want someone to have to go to something like example.com :8080 to access your site. Nobody would really know that that's the port, right? Unless you told them like offline or something like that. Or, in this case, like maybe you have a dozen different apps already configured to use these standard ports here, and you've moved them into Kubernetes around the time Kubernetes 1.23 came out a couple of years ago here. And now you're finally upgrading or updated to 1.24, and now you actually started to get some type of access denied error. And that's actually what provoked me to make this blog post and video, and we're going to go over that real world use case here near the end once we start going over some of the solutions here. But yeah, let's say that using a high port isn't an option or you don't want to do that. So how can you solve it elsewhere? And that's when Linux kernel parameter tweaking comes into play here. You can use sysctl. We're going to see that command here in a bit here. So yeah, you can modify a Linux kernel parameter for your specific containers that need this type of access, right? This can be done in a Docker Compose YAML file or whatever Kubernetes config file that we're going to look at later here if you want to modify this type of thing. But before we get into code here for a sec, let's just look at the parameter. What does it actually do? What is it, etc.? What does it default to? And it's this one here, IP unprivileged port start equals 1024. It is a network parameter that we can tweak here. And it's literally kind of how it reads. So it lets you define which port number no longer requires root access to use. For example, let's say that this is set to 42. Then ports 1 through 41 will require root, but 42 and above will not. Why? Because unprivileged port start is 42. So 42 is the port that you can start using if you're unprivileged. So if you're running a Linux system here, you can actually run this command in your terminal or whatever, maybe even Mac OS, not 100%. But yeah, let's see what happens when you run this command. So in my case, I'm running WSL2, which is running native Linux, running Ubuntu 22.04 here. And on my system, it's set to 1024. I didn't modify that. I don't want to modify that. That's what I want for my normal system here. And you probably have that too, unless you happen to modify it or your distro modifies it for you. But if you were to check out a running container, you'll notice that you get probably back a much different value here, depending on when you have Docker installed. So for example, I always run my Flask application here, and it actually doesn't have sysctl installed by default here, but the Rails application happens to have that. So if I run docker compose exec web bash here, and no configuration, would actually help if I were in the Rails directory here for the second terminal. So let me rerun that one. Now we're in a shell prompt here, and I can actually run that same exact command that we saw before, and we can see here that it is set to 0. Now, if we look very quickly here at my compose.yaml file, I don't want to spend a lot of time here because the answer is there's literally nothing indicating here that I did anything custom. So I actually did not have to modify anything for this to work. And Docker automatically sets this value to 0. So let's go back to the blog post here where we can look at some stuff here. So yeah, the good news is, right, as long as you're using a version of Docker that's newer than 20.10.0, which by the way, if you click that link there, that came out all the way back in 2020. So quite a few years ago here. There's a link to a pull request, which we're going to check for a second. Not going to really go through it because there's a lot of stuff there. But yeah, if you're running any reasonably modern version of Docker, Docker will automatically set this kernel parameter to 0 for you, so you never have to worry about it. But yeah, that's thanks to this pull request here that was, I don't know, mid 2020 or something. It got merged in June. So yeah, if you take a look at some of these implementation details here, you know, there is a reference here to, yeah, just setting that to 0 by default. I don't know exactly where it is in here, some Go code. I know there's a lot of test code here, trying to find like the oh yeah, right here. So it just sets this to 0, just like we did, except now we don't need to actually do it. Cool, nice, done. Okay, so if you happen to be running an ancient version of Docker and you are using something like Docker Compose, if you really need to set it manually, you can totally do that too. Set sysctl, notice the S at the end, very important there. And then you just pop in the thing that you want to tweak here. In this case, the same exact parameter we saw before, equals 0, and you're done. So if you're running a really old version of Docker and Compose, you know, I get it, real world happens, maybe you can't update or won't, then this gives you a solution. Also, if you're using Kubernetes less than 1.24, if you're using the Docker container runtime, this will work out of the box for you because Kubernetes, well, before 1.24, by default at least, the Docker container runtime was set. And then in 1.24 and above, by default at least, containerd is the new container runtime. And we noticed here that Docker actually sets this to 0 for you. However, containerd does not. So that could be a case where if you're using something like Kubernetes 1.23 and you update to 1.24 and you got permission denied, that's the reason for that one. So it's something to look at. And yeah, so unlike Docker, at least right now, Kubernetes doesn't default to setting this to 0. There is an open issue here and another potential way to make this default for containerd too. But yeah, this is an open issue for a while here. And if you look down there, eventually, like you get to some stuff that may actually happen where even containerd itself potentially may default to 0, but who knows, right? That's totally out of our control here. But we do have options to set it, you know, just like we did for Compose with Kubernetes as well. And you can do it as of today, it's no problem. So as long as you're running something like Kubernetes 1.22 and above, and technically you can still use it below, you know, in 1.22, well, before we even get to that, before you can modify any system or Linux kernel parameters, it needs to be either marked as safe or not safe. And if it is marked as safe, let me see if I can zoom in a little bit here, a little bit easier to read here. If it's marked as safe, you can actually just start using it. There's nothing you need to do for your Kubernetes nodes to just do it. You just pop your configs in and go. And Kubernetes themselves, like, you know, the folks developing the project, you know, they make this classification of like what is safe versus unsafe. So in their context here, safe basically means that this is only going to influence the pod that you are setting the setting on. There's nothing, you know, about this property that will affect the health of the system, like, you know, to gain CPU or memory outside the resource limits of a pod here, or, you know, modify the node's health or any influence at all on any other pod in the node. So here's a list of all things that are safe here, right? You can do all sorts of different things here, but also one of them is the property we just looked at before. It's totally safe. Now, if you want to use something that's unsafe, then you actually have to explicitly run a command against your cluster on each node or whatever, and then enable the ones that you want. We're not going to get into that into this video because we don't have to. But if you're running a really old version of Kubernetes at 1.21, then check the reference links and you can get into that if you like. That's quite an old version of Kubernetes here. So with modern version of Kubernetes, then yeah, you can just set the security context on the pod. and just set again sysctl with the s at the end there, and you just say, yep, unprivileged port start 0, and that's it. You apply it and you're good to go. But is it safe though? I mean, honestly, I'm comfortable using that as a solution. Like Docker literally sets it as a default value, and it may become a default for Kubernetes and Containerd too, right? Who knows? But honestly, even if they're not going to be made as a default, I'll still think the same way, right? We know load ports aren't inherently less secure. We also know that this pod has its own complete network, and it's isolated to the pod there. Yeah, and it's been marked explicitly as safe by Kubernetes, and I don't know, to me, that is enough to be like, yep, that is totally good. And yeah, once we go over a couple more things here, we're going to jump in and start looking at some of that stuff in a Kubernetes config and applying it, and yeah, just seeing how it actually works. And here's a third option, which is setting capabilities. So capabilities are a Linux feature where you can give an unprivileged user specific capabilities that normally require root access. So there's the man pages over here. And now let me zoom in a bit. I'm not going to go over a lot of this stuff, but yeah, there's just a lot of different capabilities, like anything that you see here, like set cap or whatever pcap there, or set UID, and all other different things here. So you can actually say for this user, let's give them a capability to do something. And that something in this case would be netbind service, or technically cap netbind service, but inside of Kubernetes, you don't need to put the cap there because it's already a capability. So that is another way to do this one here. One of those capabilities is this one, right? That's you bind to a lower port. So you wouldn't need to use this in addition to using the Linux kernel approach over here. You can use that as an alternative to that one. But this could be done without modifying the Linux kernel parameters that we mentioned right before, right? And this can also be set in Compose and Kubernetes. There's actually no reason to use this in Docker if you're using a modern version of Docker and Docker Compose there, because you're already getting this by default, which gives you the behavior already. So there's no reason to really set that capability here. And yeah, with Kubernetes, you can also set this one on the container, not the actual pod itself. So yeah, you just use security context here, you drop everything, and then you say add, and then you want that. So basically nobody can do anything as an unprivileged user that they wouldn't want to do, like things that would typically require root, except for that. But there is this one open issue on Kubernetes that hints using this along with allow privilege escalation false can produce some weird side effects here. And this comment is really long, not really long, but like there's a lot of discussion in here. And yeah, I read through this a little bit, and you know what? If I'm running something in production, like I don't want weird interactions in surprising ways. I just want the thing to work. And a lot of people, not a lot, let me rephrase, quite a few people or some people, they indicated that using the Linux kernel approach is potentially better, or just, yeah, like just use whatever you need here. I'm not saying one is necessarily 100% better than the other, but when I put all these things together, yeah, well, personally, I didn't explore this option, by the way, I should mention too. I didn't really explore it in super detail here, but I don't know. The Linux kernel parameter approach to me felt pretty sound. Plus again, like I don't know a massive amount about Linux capabilities, and yeah, honestly, I just don't want to use something in production that I don't really have a super sound understanding of. But based on the research I did here, the kernel parameter approach feels better to me at least. So performing a deep dive and like learning a little bit more about capabilities didn't really feel warranted for this use case. I love going down rabbit holes and learning a lot about a lot of things, but I typically do them when I'm driven by a real world use case, and just casually learning about this or learning this in detail didn't really feel that great when I have the kernel parameter approach that just totally worked. So yeah, let's go over some use cases, actually running commands and looking at things before what actually led me down this rabbit hole entirely, because I mean, that is a nice little side story, I guess, but it's probably more important to see how these things work. So let me kill off this server here, and no need to be running this one now. And I do have a Kubernetes cluster running already here. And by the way, I'm running this with Kind, running basically Kubernetes and Docker. I've done a video about that one in the past using Terraform to set all this stuff up here. So this cluster is running technically, and I think the app might not be running here, but let's take a look really fast at it first. So it's a little demo application that I put together here. It's essentially just a little echo server where it echoes out some headers back using an open source tool here from JMalek, echo server. And yeah, there's some stuff commented here that we're going to get to in a bit here. But I just wanted to let you know at a super high level, again, I'm not going to focus hardcore on the Kubernetes fundamentals here, but we do have an ingress pointing at just slash here. There is a server set up for this ingress here that's connected. And then we also have a deployment here, which is just running this echo server. This could be your web application. This could be your Nginx, and then combined with your application, whatever, as two different containers here in a pod. Done. Okay, so this thing by default will actually bind to port 8080. Now, as we learned, 8080 is a high port, so you don't need root access to access that. So there is one config option for this in the documentation for this open source Echo server, where if you set the port environment variable to 80 or whatever you want, then it is going to bind to that port instead here. So yeah, if I go and try to apply this into my Kubernetes cluster here, and we can just do that on demo.yaml. And by the way, yeah, I'll leave a link to this whole config file in my blog, and then you can just copy paste it if you want to do the same thing here. But yeah, in this case, you can see the deployment, service, and ingress are created here. And if I curl localhost just like this, then we can see that we do get, there it is. Like this is the Echo server, basically. You know, I'm just curling this, I'm getting this information back here, and we're getting all sorts of good stuff. And cool. So this thing is running on port 80. But the thing is, this is actually running as the root user by default. There is nothing about the internals of this Docker image that say to run this as a non-root user. Normally, if you're developing your application here, if I go back to, I don't know, the Rails application, doesn't really matter, because I have Flask, Django, and Phoenix and Node examples as well. You know, typically you'd be adding a custom user here, and I've got videos all about this, you know, kind of covered that before. It's linked if you want to go and check it out. But eventually you're going to be switching to a non-root user, and then everything below that is going to be executed as this non-root user, meaning in this case, it's going to be running Puma, you know, like an app server for Ruby, and it's going to be running as a non-root user. But in this case, that doesn't happen. Now with Kubernetes, you could do things like, hey, just run this as a non-root user, basically user ID and group ID 1,000,000, just like we saw with that example here. You know, it's running as UID and GID 1,000,000. You can tweak this if you'd like as well, but yeah, so let me just start with doing that. So let's just start by modifying this config file to say, let's run this as a non-root user 1,000,000. And I'm also going to just delete this first, just in case, because Kubernetes, you know, spoiler alert, this is going to fail to run, I'm pretty sure. And then it's going to try to roll back and the other one's going to work. And then it's going to be like, wait, this isn't working how we want it to. So we're just giving it a completely fresh state. Deleted everything in the cluster, now it's back in. And if we run like a, you know, well, I have an alias for kubectl, like this, then we can just see everything. Well, I can't spell. It's kubectl. There we go. We can see everything running in the cluster here. We actually see right away that, oh, we have a crash loop back off. What's happening? So if we actually try to go to curl localhost here, then this is going to hang or whatever. We get a 503. So there's no way to reach that. So what actually happened? So, okay, let's copy this here and just do, you know, kubectl logs on the pod. And what happened? Oh, wow, look at this. We got listen TCP 80 bind permission denied. Looks awfully familiar to that error from the beginning of the blog post here. I think this happens to be a Go application here, we can see, but you know, that's the type of error that you get back with a Go app. But it got permission denied. It can't bind to that port. That's a big problem if you're trying to run as a non-root user. So yeah, like we say, we can do things like just make this run on a higher port and we can solve that problem. But let's say you can't do that or you won't do that or it's too complicated to do that because you have like, you know, a million different applications where, I don't know, making those changes is, you know, not viable for your use case. Maybe you're not using whatever. Okay, cool. How do you fix it? Well, you know, going back to the blog post that we were just checking out here, we can do specifically this. So we can security context, STLS, and then we just set that. So let's go back to that and just uncomment these lines here. And notice that, you know, this is actually happening here on the deployment. For the template spec here, we've got security context. We are running as a non-root user. Here's our sysctls with these values here. And cool, let me save that here. And also we will destroy this completely, and then I'm going to up it again, or apply it, I should say. And then let's do get all here. Again, that's my alias for kubectl here. And this time around, it runs. We can see 4 seconds ago. Cool. So now let's take a look here at, well, before we even look at the logs, let me do a curl localhost. Does it actually work? And it works. Cool. And if we take a look here at the logs, we can do get logs there, and then we can see we got the correct logs here. And if I hit this a couple times here, you know, let's say 3 more times, we're going to see what, 4 logs, I guess? Yeah, because there was one before. 1, 2, 3, 4. Nice. So we are now technically running this as a non-root user. Everything is hooked up to port 80 and we are totally good to go here. Now, of course, with Kubernetes too, right? Technically, you know, if you don't define a target port, your port and the target port will be the same number here, but I split them out here just to demonstrate, you know, in case you wanted to play around with changing this to a higher port instead. But yeah, that's that. And then also here's the security context for capabilities. Notice that it's in a completely different area. This is actually set on the container itself, you know, not this template here. So I'm not going to bother going over that, but this is the exact syntax if you wanted to use that instead. And yeah, that's basically that. So anything else to go over live demo wise? I don't think so, but yeah, again, these commands and things will be in the blog post if you want to repeat that on your own there. So now let's go back down to here, right? So what led me down this whole rabbit hole, right? Because I didn't just wake up today and you know, being super eager to write about this topic here. I was actually doing some client work where they have a dozen web applications and they're all using Apache as a reverse proxy. It's basically your typical PHP-FPM/Apache setup. PHP-FPM, again, is the equivalent of something like Puma with Ruby or Gunicorn with Python, in the sense that, it's your app server that runs, and then you have a reverse proxy in front of that one, like Nginx or Apache. So this application is well over a decade old, and its runtime history is basically this. So it's Apache listening on ports 80 and 443 without Docker and no load balancer, basically on a server. And then Apache listening on ports 80 and 443. I'm not going to repeat that every time, by the way, but without Docker. And then there was a load balancer. And then after not using Docker, then it was with Docker Compose and a load balancer as well. No Kubernetes yet. This is basically just Docker Compose in one server with an AWS ALB in front of that one. And yeah, eventually it migrated into Kubernetes 1.20 or 1.22 with a load balancer powered through Kubernetes there, which is also using the ALB through the Kubernetes AWS load balancer controller. Then Kubernetes 1.23 and then 1.24 here. And I basically came in at step 3 here. And again, we're talking like literally over a decade here. This is quite a few years ago here. And I helped them Dockerize their apps and, eventually move into using Kubernetes because, for their actual use case, it made sense. They had separate teams, separate services, like just setting up all these different EC2 instances manually not manually, but with Ansible and things. It just became pretty tedious. But, yeah, it's been super smooth. Really happy with that decision. Everything is good to go. Like current day, we're running 1.27 with intentions to upgrade every 6 months here. But when I attempted to upgrade from 1.23 to 1.24, I started to get an access denied error on Apache, but only in the test cluster. It didn't happen locally in Docker Compose, and it didn't happen in CI with Docker Compose as well. And, of course, I looked at the changelog and things before I did these upgrades, and, we have a test cluster and all this other stuff, but like I knew the container runtime was changing from Docker to containerd, but at the time I had no idea about this parameter, and I had no idea how it related to Docker, Docker basically setting it by default. So like when it didn't fail locally or in CI using Docker Compose, but then it failed in Kubernetes, it was like, what's going on? Time to do some research here. So yeah, just a lot of Googling, but yeah, so anyways, like each app has its own repo and its own copy of Apache. Both PHP-FPM and Apache run in one pod as 2 separate containers, pretty standard setup here. And I just did not want to make 12 separate updates to all of the repos here. So I Googled around a little bit here and ultimately led to, basically this whole blog post and video that you're watching now. And it was solved by literally modifying customized based web deployment there in one spot to set this security context, and everything immediately worked. So yeah, there's, a fun little takeaway there. Like too often our solution's pretty easy once you actually know the problem here. And then yeah, whatever, this is like now inception mode where it's like the demo video literally goes over the video that you just watched. So yeah, that is basically it for this one. I'd be curious, like in the comments below, yeah, what method have you done to solve this problem in the past? Was it using Linux kernel parameters that we went over? Was it using a high port? Was it using something else? What was your use case? Were you using the load balancer, etc.? That'd be kind of cool to know. And also, if you liked the video, please give it a thumbs up because it really does help a lot. Thanks a lot for watching, and I will see you in the next video.